Hi, I'm Barney with DPReview, and I'm here with Ariel Braunstein of Lytro. Hello.
Thank you for having me.
Thank you. So let's talk a little bit about the camera, the Lytro light field camera, the Illume. Here it is. John, just give me a really quick overview of
Sure.
why this is a little bit unusual.
My pleasure. So this is the second generation of Lytro's light field camera. It is designed from the ground up to just think of images in a different way. It has a built-in light field optics. This is a 30 to 250 millimeter f2.0 constant throughout the range. It's an amazing lens, and what's interesting about this lens is that it doesn't actually focus image on the sensor, but actually it allows to capture. We have a 40 mega ray sensor, and that sensor captures every light that travels through this gigantic aperture into the sensor to create a three-dimensional model with one click through one lens, a three-dimensional model of the scene. And that scene is then reconstructed both on the camera for preview, but then on a computer using our software to create things that were not possible previously in photography. For example, the ability to change the aperture of the shot after it was taken, or the ability to focus on different things, or to simulate a tilt shift a camera where you can rotate and tilt the sensor. You can simulate any kind of camera and any kind of exposure. It's really a new way of thinking of photography.
So it's totally different to just focusing light rays on a two-dimensional plane. Light field
completely. When photographers start using Illume and the light field camera, they go through a transition. Instead of for years composing just a 2D shot, suddenly there's a volume to it. And that volume matters because a good, what we call living picture, meaning the output is no longer just a 2D image, but a living picture. A good living picture has a distinction between the foreground, the midground, and the background. And that volume matters as you start interacting with the image because we can actually animate how you change these controls.
Let's have a look at this. I know you've got a little demonstration. It's
yes,
going to be much easier to show than it is to describe. So let's see.
Excellent. So this is the Lytro desktop application, and these are my personal shots from weekends and different things. And let's look at, here's a picture from the Arcade Museum in Pier 39 in San Francisco. And it's a nice macro shot where you have this different depth. And look what I'm doing. I'm just focusing on different things.
How tall are these figures?
Okay, they are probably, my guess is about 4 inches each character, right? So I'm against glass. I'm actually taking it through glass of this arcade machine. And I can go and adjust this image. So the first thing you will see at the top is the fact that I can change the aperture of the shot after the fact that I shot it. So right now it's somewhere around f3 and I can bring it to f16.
So this isn't just adding a blur effect, is it?
No, no, no. This is an actual simulation. This image is actually not a photo. It looks just like a photo, but it's a rendering of data that came from an optical system to create a three-dimensional space. And in that space, I can simulate the exact, I'm moving the f-stop right now, I can go all the way to f1. Right? So I'm right now focusing on different portions of the image at f1, creating a representation of it. But wait, that's not all, right? Let's move it to f2. So here's this image, and now I can start moving the perspective of this image. It's living in space. You can actually see the image from different angles until you get the exact right perspective for that shot. Now, once you do that, you can also start building animations. So for example, a default animation for this image is this. You can see it's a fly through the scene. Right?
And this is a single exposure.
A single exposure. Yeah. It's one shot capturing the three-dimensional data. And now you start thinking about, okay, how would I tell stories differently? How would I look at my art or my project in a different way, in a different light? Because you have these abilities to change the aperture, change focus, and animate all at once. Now, in addition to that, we have all the standard controls about tone and saturation and sharpening and
everything
all that.
You'd see in Lightroom or in...
Exactly. Yeah. And we actually encourage our professional photographers to we allow them to edit these images in Photoshop and bring them back in. So we never claim to be the best company for image processing. Adobe and Apple are doing a phenomenal job. Well, Apple is a little out of that game now, but at least Adobe is doing an amazing job there. And we are trying to enable the photographers to do things that they cannot do in other systems. So the ability to export in and out is built into it. And now look at this. Here's the tilt control. So I have a virtual camera. Let's say that I start with a focus here. Now I'm going to tilt the sensor. So imagine you have a tilt your camera and I'm tilting the sensor. Okay, here, it's tilted. And now I can start rotating it. Right? So you can see how I can create these amazing things where this person is focused and this person is focused, although they're completely in different planes, because I have a tilt shift camera that is completely virtual, and I can take it with me anywhere that I want. Right? Let's look at some other photos so you can see. Here is my son chasing a seagull. Let's take this guy over here. So again, right now I'm at F2. Let's shift it to F1. So I can focus on the seagull. I can focus on my son. I took this image completely running with the camera on the floor, right, trying to get this thing. And it has its own space. And the reason I'm doing this is a little gimmick. It just, the idea is not to be gimmicky about it, but the idea is to get a sense of the depth in the scene. So now you can start applying things to it. And over time, you will see how we push the technology to start using that depth, not only for composition, but also for editing. So
when you take a picture with a light field camera like the Illum, I mean, what does focusing mean now?
That's a great question. So a lot of other cameras are building all these complex mechanisms to track what you want to take a picture of and get the focus just right. Right? And they build in burst modes to take tons of photos all in succession, rapid succession, to make sure you get that magical shot that you wanted to.
The best one out of
the best one, because they know that many of them are not going to be the one that they wanted. Well, for us, it's more about what we call the refocusable range, meaning the camera is built such that you can actually focus on things touching the lens. If you, in light field photography, if you do not clean your lens, you might get a fingerprint or dust in your shot because it will be part of the composition. So you have to be very careful. And there is a range that you can refocus. So for us to focus, it's much more about where do you want to place that refocusable range. And in the camera, we add, in real time, you can see an overlay of colors on top of your picture that describe to you what is the refocusable range within your scene to help you compose it. And photographers go through a transition, thinking about, okay, I need to think differently. It's not about the mechanics of capturing the shot in the best technical way. It's about releasing some of these mental constraints, thinking about your composition, thinking about what you're trying to deliver, and then using your computer to come up with the perfect shot. And what we discover is that many photographers say that when they are able to disengage and do that, when they come back to their office, when they come back to their computer, they discover shots that they didn't know were there. Because now, when suddenly changing perspective and creating different focus and changing the aperture, they get to a scene, a shot, that was just magical and was not in their intention.
This is I mean, we talked this morning on a separate panel,
right.
And I was talking to you about the analogy I tend to use around light field, which is like, it's the first time someone introduced you to shooting RAW.
That's
still
right.
cameras.
That's right. All this power that is hidden in there.
You can mess up a shot, go back, use the
right.
RAW file, fix it, find new ways of getting the picture the way you want it.
That's right.
But this is adding, I mean, literally another dimension to it.
It's adding multiple dimensions to it, right? So there is literally a third dimension to the composition and the data. But there is so much more that we will be able to enable in coming generations, as we start allowing you to think of your shot in terms of what you will be able to do when you edit it. So, per your analogy, when you shoot RAW, you allow yourself to underexpose or overexpose, but you know you have enough dynamic range in that shot to edit it later. What if, as you take a shot, you know you can eliminate or treat differently the background from this foreground? Or you know you can take portions of the image and change perspective to look at things that actually you weren't sure you can see. And this is more how Hollywood is producing a movie, right? You compose a shot knowing that it will go to post-production. In post-production, you'll be able to add a lot of magic to it. Well, that is what we're trying to do. We're merging between computer graphics and photography. We're simulating photography through computational photography and allowing, putting a lot of power, giving a lot of power to the photographer through the artist to express themselves in ways that maybe they even haven't thought of it in the time of taking the picture.
I think actually that raises a good point. I think one of the challenges that you've admitted that Lytro has is a messaging issue. It's really complicated for some people to get their heads around this. I mean, how do you send that message? I mean, you're not aiming for huge sales of this camera, I'm sure.
That's right.
But how do you get people to lock into the concept?
So, you know, we are, Lytro has been a long journey. The first generation has been an amazing engineering success because the first light field camera built in an amazing little form factor.
That was just called the light field camera.
Right, and that was much more about people just experimenting. What does it mean? All the excitement around this. This is the first time that we're putting it in a package that suits the needs of professional photographer. This is not meant to be somebody's only camera. This is an additional tool in the bag that allows you to do things that otherwise you wouldn't be able to do. Mm-hmm. As we push the technology forward, we will get to the point that we hit parity with DSLRs, and then far exceeds them, to the point that people will say, I can imagine the point in time in which people will say, remember the days that we had to take all these photos every time we wanted to take a picture because we weren't sure which one will work? That will happen. Remember the days that when we took a shot it was locked, we couldn't do more with it? Remember the days? This is coming, and it's not coming in 10 years. This is coming rapidly. And we're going to, we're committed to a pace of innovation that far exceeds, other innovations in just silicon growth. So we've already quadrupled the resolution between Gen 1 and Gen 2. We are committed to quadrupling it again. So think of it, this is 40 megaray, right? So we're going to quadruple it in the next generation. And we have a roadmap that continues to quadruple it to the point that the authenticity of the three-dimensional scene that we can render will be so precise that we can literally allow photographers to do post-production in the quality that Hollywood are getting us used to, right? It's sort of photorealism that exceeds realism, allows you to have to sort of super realism. And that's just an amazing and exciting task for all of us.
So megaray is a term that a lot of people watching this won't necessarily be familiar with. And what does 40 megarays equate to if you were going to put it in two-dimensional photography terms? What kind of resolution is that?
So the way it works is that you have a sensor underneath it. And we're building very highly specialized sensors, but eventually it is a sensor. But on top of the sensor, we have what we call the micro lens array. It's an array of thousands of tiny lenses. And those lenses are allowing us to have an array of, imagine it as thousands of tiny cameras. And because the density of the sensor is so great, we are able to detect each individual ray of light that goes through these microlens and compose. If people are used to stereoscopic photography, we have two cameras, we have thousands of them, in the tens of thousands of those, right? And we will keep on pushing it to the point that the amount of information that we can collect from the scene will allow us to reconstruct it in that level of accuracy that will allow us to do everything we're doing. And already, it is an amazing tool for people who want to tell stories in a different way, to look at a scene in a different light, to differentiate their work from what's out there. And I highly recommend for people to go to pictures.lytro.com to look at what professional photographers are doing with this tool. It is remarkable. It is the biggest compliment to product company is simply to see what the things that people do with it that we never even planned or thought of possible. And that's the greatest compliment.
Especially with a product like this. I mean, just quickly though, what kind of resolution does this put out? Like if you had to do it in conventional camera terms,
right? So
5
it's
megapixels?
Interesting. So when you have a three-dimensional model, you can render it any megapixel you want, right? You can render a 100 megapixel image, right? It's all a question of, do you have enough data to have the clarity, the crispness? Right now, we produce an image. When you export it into a JPEG, we export it at 4 megapixel. Right? So this is not meant as a medium for print. You need to think of it in the sense that this is an interactive medium. This is a medium that allows you to go into screen displays online. And as we spoke this morning about 4K, the revolution in 4K is that it will redefine what consumption medium looks like. It's no longer print. The fact that somebody can print from that resolution, great. For a while, there will continue to be print, or for a long while. But the primary consumption will be online. The primary consumption will be through displays. And we are building cameras for the new generation of consumption of media, not for the old generation.
Sure. So in terms of stills, you say this is 40 megarays now, and it's going to quadruple in the next generation. Yep. So presumably then we're looking at whatever it is, 10 megapixel, 12 megapixel stills if you were to do that.
Yeah.
But thinking about video, I mean, right now this camera cannot output video. But we spoke earlier on. Presumably there's huge potential here for videographers.
Absolutely. Huge challenges technologically and huge payoff in terms of what we can add. Imagine video. Video is the ultimate medium that is basically flat. Once you captured it, that's it, right? Because there's so much data there, it's already composed into a format that captured exactly that focus plane, and that's it. If we can build a three-dimensional scene, 30, 60, 120 frames per second, at 4K resolution, we allow for the video camera to be completely virtual, where you can, after the fact, set the aperture, set focus, tilt the camera. You can do anything you want and start doing editing based on depth. That is completely unheard of. It's completely science fiction, and it is coming rapidly.
So the roadblock to that for now, the temporary roadblock, is just computational power. Presumably.
Computational power, storage, data throughput. It's just the amount of data that we're dealing with is unheard of, and we are literally bound by what Silicon Valley and companies around us are allowing us to have. Sort of, we are working closely with the best companies out there, but we're limited by battery technology and sensor technology and optics and computational power, the CPUs and GPUs. So we have a role in this ecosystem of pushing everybody and getting to the point where it's no longer science fiction, and it is real. It's already real. The things that we're building in next generation are even more exciting and getting us even more closer to that vision. And I will not make comments about the exact things that we're building, but it's coming.
Great. So for now, early adopters, this is the Lytro Illum.
That's right.
How much is this, remind me?
It is $1,600, and it is, the way I would describe it, it's a tool for what we call the creative pioneers, meaning people who want to be on a cutting edge, who are not afraid of exploring with new technology, and really are great at expressing them, looking for new ways to express their art and their passion. And it can be both professionals and passionate amateurs.
That's fascinating. Thank you very much, Ariel. This is a really interesting overview. Thank you.
Thank you so much.
And thank you for watching.